Hi everyone, I hope you're all doing well and staying safe at home. Today we're going to talk about inverse values. Let's start with this warm-up question first. How does the bow tie trick help us find the location of an angle? Well, we have learned before that if we have a unit circle and we consider a point like this one, for example, on the unit circle, this point has x and y coordinates. We learned that x is basically cosine and y is sine of the angle which is made between this line and the x-axis. So let's call this theta. So x will be cosine of theta and y will be sine of theta. On the first quadrant, we know that always x is positive because it's on the right side of the origin. So if x is positive, that means cosine is also positive. And y value also is positive on the first quadrant, so sine is also positive. Now what happens to tangent? We know that is tangent of theta is y divided by x, or we can also say sine divided by cosine. So because sine is a positive value, cosine and also cosine is positive, then tangent is positive divided by positive, which is a positive value. So tangent is also a positive number. Then on the second quadrant, if we consider this point again, this point has x and y coordinates, and again x is a negative value here because it's on the left side of the origin. So that means x is negative, that makes cosine also negative. Y is still positive because it's above the x-axis, so sine is going to be positive as well. Tangent here will be a positive value over negative. Positive over negative, so it's a negative value. So this is our tangent. On the third quadrant, x and y are both negative because x is on the left side and y is below the x-axis. So that means sine and cosine are both positive. And tangent will be negative divided by negative, which is a positive value. So here tangent is positive, but the other two are negative. On the fourth quadrant, x is a positive value, but y is negative. That means cosine is positive, but sine is negative. And then the tangent will be negative divided by positive, so it's a negative value. So this is how we can say the sign of trig values on different quadrants. But since all these positive and negative values are not easy to memorize, we can use this phrase, all smarties takes calculus, to memorize these values. How do we do that? Each word that you see here are related to one of these quadrants. The first one, all, is related to the first quadrant. A stands for all, so that means all the trig functions here are positive. Second one, smarties, relates to the second quadrant. S stands for sine, that means only sine is positive. Third one, take, is for the third quadrant, and T stands for tangent. So only tangent is positive and the other two are negative. And then the last one, calculus, is for the fourth quadrant. And C stands for cosine, that means only cosine is positive and the other two are negative. So we use this bow tie and this phrase in order to figure out the location of the angles based on their sign, like positive or negative. We're going to use this a lot for the next problem that we're going to solve. So let's start the inverse values here. We're going to learn how do inverse values relate to the unit circle. First of all, let's see what is an inverse value. If you remember, we said this is sine of 30 equal to 1 over 2. This is basically exact value. Like we say, exact value of sine of 30 is equal to 1 over 2. So exact value of sine of 30 degrees is equal to 1 over 2. If I want to undo this sine function, I need to use sine -1, or the inverse of sine. The inverse of sine is also called arc sine. So if you see arc sine, that's basically the same as sine -1. Or inverse of cosine is cosine -1, or arc cosine. Tangent -1, or arc tangent, and cotangent -1, or arc cotangent. So these are all the inverse functions. Now let's go back here. If I want to undo sine, I'm going to use sine -1, and I need to apply this for both sides of this equation. So this will be sine -1 of sine of 30, and on the other side I'm going to have sine -1 of 1/2. We learned that these two can cancel each other because they are inverse of each other. So on the left side, I'm going to have 30 degrees is equal to sine -1 of 1/2. Basically, we can say that inverse function is equal to an angle measure. So if you see an inverse function, that means we're looking for an angle measure. So we can say there is an angle, let's call that theta, that sine of that angle is equal to 1/2 in this case. And what is that theta? That's 30 degrees. Okay, so let's do an example here. We want to find the inverse value of cosine -1 of 1/2 for x between 0 and 2 pi. That means the angle that we are looking for should be between 0 and 2 pi. So let's start here. Cosine -1 of 1/2. That means there is an angle, let's call that x, that cosine of this angle, cosine of this x, is equal to 1/2. So we're looking for this angle. What is this x equal to? What is this angle equal to? As you see, this cosine value is a positive number. So based on the bow tie that we just talked about, on which quadrants cosine is a positive value? On first quadrant and the fourth quadrant. So I'm going to start from here. First of all, I'm going to make my right triangle, and then I know that cosine is adjacent over hypotenuse. So I'm going to use this. This angle that you see here is the angle that we are working on. Is the reference angle that is made by this triangle, and also the other one is here. So we're going to have two answers. The angles that we are working on are going to have these terminal sides. So first of all, we're going to find the reference angles, and then we'll find the original angles. So on this angle, this is my x. On this triangle, the adjacent side is 1. And the hypotenuse is 2. So it's here. This is 1 and this is 2. On the other one also, if I call this x, the adjacent side is this 1 and the hypotenuse is 2. So I'm going to find the other side for each of these triangles. Let's call this a. I can use Pythagorean theorem to find the missing side. So I use a squared plus b squared equal to c squared. A squared is what we're looking for, b is 1, is this side, and c is the hypotenuse, which is 2. So this will be a squared plus 1 equal to 4, and I subtract 1 from both sides. A squared will be 3, and from here a will be plus and minus square root of 3. So this side, a, is basically root 3, and the other one will be negative root 3 because this is on top of the x-axis, so this is positive and the other one is negative. So I have my right triangles here. If you have a closer look at the ratio of the sides, you will see that those are the same as the ratio of 30, 60, 90 triangle. So opposite 60 is root 3. Opposite 60 is root 3. That means this angle x is basically 60 degrees. Since I'm working with radian, I'm going to change this to radian form. So instead of writing 60, I'm going to write this as pi over 3. I hope you all remember that pi over 3 is equal to 60. If not, this is why that's equal to 60. Pi is 180. Divided by 3 will be 60 degrees. So what I found here is theta reference. I found the theta reference. The same is going to be here for this one. This is also pi over 3 because it's opposite root 3, and we ignore the negative. Okay, so I found the theta reference. Now I need to find my original angles. What are my original angles? The two answers that I'm looking for. I have two terminal sides. One is this one and the other one is this one. We know that we always need to start from the positive side of the x-axis. That's the starting side. And which way should I go? I need to go to the direction of positive because the x should be between 0 and 2 pi. It means we need to start from 0 and then move this way, make the whole circle and come back here at 2 pi. I can't go the other way because that's negative direction. We are looking for the angles which are positive and between 0 and 2 pi. So I'm not going to go this way. I'm only going to move this way. So starting from here, I move and then I reach to the first terminal side. So this is my first angle. Theta 1 is the first answer, and it's equal to just simply pi over 3. How about the other one? The other one will be starting from here, 0, and then we can move. Let me draw that here. Move until I reach to the next terminal side. So this will be my theta 2. But how do I find the measure of this angle? The easiest way is that you say if I have made a full circle, that will be 2 pi. Now if I just subtract this pi over 3 from 2 pi, I'm going to reach to this point. So to find the measure of this angle to this point, I can just subtract pi over 3 from 2 pi. Okay, now I need to have the same denominator, so I'm going to make denominator of 1 here and multiply both top and the bottom by 3. So this will be 2 times 3 is 6 pi. I have two equal signs here. 6 pi divided by 3 minus pi over 3. And that will be equal to 5 pi over 3. And this is my second answer. So first one was pi over 3, the next one is 5 pi over 3. Now let's work on the next problem. Arc sine of negative 1 over 2. As we just talked about, we said that arc sine is the same as sine negative 1. So we have an angle here. Let's call that theta. That sine of theta is equal to negative 1 over root 2. So the sine is a negative value. Which quadrant should the angle be? Yes, on third and the fourth, because on these two, sine is a negative value. Okay, so I'm going to start with making my triangles. Notice that always we make the triangle by using the line of the angle and the x-axis. So this is the angle that I'm working, this one and this one. I'm not going to make my right triangle using the y-axis. The triangle is always made with the x-axis. So these are my angles And now sine is opposite over hypotenuse. So opposite side is -1. Opposite side of this angle, which is theta, is -1. The same is here. This is my theta, it's -1. And then the hypotenuse is √2. Why I didn't put the negative sign for the hypotenuse? Because we know that hypotenuse is always a positive value. Okay, now I'm going to find the other side, the missing side. Okay, again, I'm going to use the Pythagorean theorem. Let's call this A. I'm going to write it here. Again, A squared plus B squared equal to C squared. A is what we're looking for. B is -1, so this is -1 squared equal to C, which is the hypotenuse, is √2. So this will be A squared plus -1 squared will be +1, and √2 squared will be equal to 2. And if I subtract 1 from both sides, A will be equal to, A squared will be equal to 1, and A will be positive and -1. So this A value is going to be +1, and the other one is -1 because it's on the left side of the x-axis, on the left side of the origin. Okay, now let's have a look at the ratio of the sides. Ignoring the positives and negatives, I see that they are the same as the ratios of 45, 45, 90 triangle. That means this angle, which is opposite one, is 45 degrees. Once again, because I'm working with radian, I'm going to change this to radian. So this is basically pi over 4, because 180 is pi, and divided by 4 is 45. So that's why 45 is pi over 4. Okay, so the same is here. This angle is also pi over 4. So I found the reference angle. Theta reference is pi over 4. Now I need to look for my original angles, the original answers actually. So I start from the positive side of x-axis, from the 0 point, and then I continue moving to the positive direction, and I stop here. So how far did I go? I need to find the measure of this angle. Theta 1 will be equal to, if I start from here, from this point to this point, I have gone pi to the positive direction, and then I need to go pi over 4 more to reach to this point. So this is basically pi plus pi over 4. Again, I need to find the common denominator. The denominator here is 1. I multiply top and bottom by 4. So this will be 4 pi over 4 plus pi over 4, which is 5 pi over 4. So this is the first angle. Now let's find the second angle, theta 2. This time I need to move from here. Let me use another color. I start from here and I go to the positive direction and stop at this point. Now what is the measure of this one? Like what we did before, to find the measure of this one, because this is closer to 2 pi, I'm going to use that 2 pi, which is the full circle, minus this little one over here, which is pi over 4, will be the angle that I'm looking for. Again, we need to have the same denominator, multiply by 4, so this will be 8 pi over 4 minus pi over 4, which is equal to 7 pi over 4. So that's my second angle. Okay, now let's go to the next problem. Cosine -1 of -√2 over 2. This is equal to an angle. So using this phrase, I can say cosine of an angle called theta is equal to -radical 2 over 2. Now, what is this angle? What is this angle? Okay, cosine is a negative value. That means the angle that I'm looking for should be either on the second quadrant or the third one. So start with drawing the right triangle, this one and this one. Cosine is adjacent over hypotenuse. So the adjacent side of the angle, this is the angle, the first one, and this one is the second one that I'm looking for. The adjacent side of this angle on this triangle is negative radical 2. And the hypotenuse is 2. Once again, we know that hypotenuse always is positive. That's why we didn't put the negative for 2. We kept it for radical 2. And the same is for this one, this angle. The adjacent side is negative radical 2 and the hypotenuse is 2. Now let's find the other side, the missing side. A squared plus b squared equal to c squared. Okay, so a squared plus b is negative root 2 to the power of 2 equal to c is 2. So a squared plus negative root 2 to the power of 2 will be equal to 2. Because, let me write it here, negative radical 2 times itself. Negative times negative is positive, and radical times radical, they will cancel each other, so this will be equal to 2. Okay, so this is 2 and this one will be equal to 4. Now a squared will be, I subtract 2 from both sides, will be equal to 2, and a will be positive and negative root 2. So the missing sides here are root 2 and negative root 2. Now, do you see a special right triangle here? You might say no at the first sight, but basically, yes, we are seeing the same thing here. Why? Because we need to find the ratio of the sides, and if we find the ratios, we'll see the same thing. How do we say that? Let me show this to you. So the sides that we have here are root 2, root 2. I'm ignoring the negatives, and 2. What if I divide them by root 2 again? Because I'm looking for the ratio, so I can divide all of them by the same number. Root 2 divided by itself is 1. The same is here, that is equal to 1. And 2 divided by root 2 is, we know 2 is radical 2 times radical 2. And in the denominator, we had radical 2. They cancel each other, so I'm left with just 1 root 2 here. And now you see the same ratios of 45, 45. So whenever you see root 2, and the hypotenuse is 2, that means you have the same ratio as 45, 45. Okay, so we figured out that we have the triangle 45, 45, and this angle that we were looking for is 45 degrees. Because it's opposite radical 2 that we said it can be written as 1. Okay, so theta reference here is 45, which again I'm going to write it as pi over 4 because I'm working with radian. It's pi over 4. Now I'm looking for my original angles. The first one is going to start from here and go here. So how do I find this? I know that if I had gone from this point to this point, that would be pi. Now I just need to subtract this value from pi. So theta 1 will be pi minus pi over 4. Again, make the same denominator. So 4 pi over 4 minus pi over 4, that will be 3 pi over 4. And then theta 2 is the angle which goes from here, let me use the red color, goes from here and ends at this point. So what is this one? This is pi plus pi over 4, because this is also pi over 4. So it's pi plus pi over 4. Again, using the common denominator, this will be, excuse me, oops, I used the big eraser. Okay, so this will be 4 pi over 4 plus pi over 4, which is 5 pi over 4. So this is my first angle, and this one is the second. Now let's go to the next page. We're going to talk about some special cases like quadrantal inverses. If you remember, we said before, when we're talking about exact values, we said that quadrantal angles like these ones, 0, pi over 2, pi, and 3 pi over 2, and 2 pi, have specific kind of like special cases of cosine and sine. The coordinate of this point will be 1 and 0. So this is cosine and this one is sine. The same here, the x value is 0, y is 1, this one is negative 1 and 0, and this one is 0 and negative 1. So if I want to find cosine and sine of these values, I just need to take the x value as cosine and y value as sine. So if I have these special cases like sine or cosine equal to 1, 0, or negative 1, then I don't need to draw a right triangle. Basically, I even cannot draw a right triangle here. I'm just going to use these coordinates to find my answer. So basically here it's asking cosine negative 1 of 0. This is equal to an angle, let's call that theta, that cosine of that angle is equal to 0. So it's not asking you to find cosine of 0. It's asking for the angle that cosine of that angle is equal to 0. So we know that cosine is x. So I need to look for an x value which is equal to 0. Where is that? One of them is here at this point. So we know that x here is 0, and that is cosine. So what is the angle here? It's pi over 2. So one of the answers, theta 1, is pi over 2. What other point here has x value equal to 0? It's this one. What is the angle related to this point? It's 3 pi over 2. We know that this is 0, this is pi, pi over 2. This one is pi, this one is 3 pi over 2, and this one is also 2 pi. So that's how we find the answer for these kind of special cases. Let's do another example. What is sine negative 1 of negative 1? What is your guess here? So there is an angle that sine of that angle is equal to negative 1. Again, this is a special case, so I'm just going to use I'm going to use the coordinate of unit circle basically on these corner points. So this point is 1 and 0, this is 0 and 1, negative 1 and 0, 0, negative 1. And now I'm looking for a sine value which is equal to negative 1. We know that sine is y value, so I need to look for a y value which is equal to negative 1. Which of these points have a y value equal to negative 1? That's here, this point. Now, what is the angle at this point? It's 3 pi over 2. And in this case, we have only one answer, not two answers. Okay, now let's go to the next problem. It says, will zeros and ones always be quadrantal, or can you draw a triangle for some? Yes. So if we have sine or cosine of the values like 0, 1, and negative 1, in these cases, we are not going to draw the right triangle. But what if it's a tangent? Yes, in that case, we can make a triangle. How do we do that? Okay, tangent -1 of 1 is equal to an angle. That means tangent of that angle is equal to 1. We learned that tangent is basically equal to y over x. This is what we learned at the beginning of the lesson today. Okay, so first of all, I'm going to start with my coordinate plane. If tangent is a positive value, so on which quadrant would my angle be? We learned that if tangent is positive, the angle is going to be either here or here on the third quadrant. So I'm going to start with drawing my right triangle. Keep in mind, we always make the right triangle by the x-axis, not the y-axis. So the other one is going to be this one, not this one. Okay. So we also know, maybe it's easier if we say tangent is equal to opposite over adjacent. It's easier instead of using y and x. Okay, so I can always put the denominator of 1 for any number that I have. Like 1 divided by 1 is equal to 1. If you have 5, we know that this is equal to 5 over 1. So I can easily put the denominator of 1 for any number that I have. And I did it here. So we know that tangent is opposite over adjacent. So opposite side is 1 and adjacent side is 1. So opposite is 1 and adjacent is 1. The same is here. Opposite is 1 and adjacent is 1. But in this case, basically, this is -1 divided by -1. And we know that the negatives cancel each other and it will be equal to +1. That's why we have positive even here. Although both of these are negative because this one is on the left side and this one is below the x-axis, so they are negative. Anyway, so we have two sides of this triangle. Now we're going to find the other side, the hypotenuse. A squared plus b squared equal to c squared. Okay, this is 1 squared plus 1 squared equal to c squared. 1 plus 1 equal to c squared. That's 2. And then from here, c will be equal to root 2. I know that this is basically positive and negative root 2, but we're not going to consider the negative. We're going to ignore that because we said that hypotenuse is always positive. So we're not considering the negative, and we're just going to say the hypotenuse is root 2 for both of these. Now, which special right triangle do you see here? Yes, we see the 45-45 triangle. So that means this angle is 45 degrees. Let's work with degrees this time, not with radian. Okay, so the reference angle that we have is 45 degrees. Now, what are my original angles? The answers. One of them is this one, which is simply the same thing as my reference angle. So theta 1 is 45 degrees. How about the second one? I need to start from here and stop at this point. And this will be equal to, this is 0. At this point, I have 180 and then plus 45. So theta 2 will be 180 plus 45, which is 225 degrees. So these are the two answers for this one. So we learned that if we have sine or cosine of 0, sine and cosine -1 of 0, 1, or -1, these are special cases, and we need to look for the coordinates of the points, like 0, 1 and 0 here, 0 and 1 here, and the rest. But if we have tangent of 1 and -1, then we need to look for the right triangle. Okay, So let's go to the next part, which is our exit ticket. What is the value of the angle x if tangent is negative? Okay, so first of all, we know that basically, I'm sorry, we had a typo here. This is tangent negative. Oh, no, it's right. Never mind. Okay, so we're looking for x here. That means tangent negative 1 of negative 1 is equal to x. Okay, so I'm looking for this x. This is a case that although the value that I have here in parentheses is negative 1, but it's not a special case. That means I don't need to look for the coordinates. I can make a special right triangle here. So I'm going to start with coordinate plane. Tangent is a negative value. That means the angle is going to be on the second quadrant or the fourth quadrant. So it's going to be something like this. These are my right triangles. Again, we know that tangent is opposite over adjacent, and we're going to put a denominator of 1 for this number that we have here, so we can match opposite by the top and the adjacent by the bottom. So opposite is negative 1 and adjacent is 1. That is going to be here. Opposite is negative 1 and adjacent is 1. And for this one, this time I can say tangent of x is 1 over negative 1. I'm going to push the negative down over here. So this time opposite is 1. Opposite of this angle is 1 and adjacent is negative 1. Basically, you don't have to worry that much about the positive and negatives at this point because we're going to just ignore the negatives. So you don't have to worry a lot about these positives and negatives. Anyway, now I'm going to use the Pythagorean theorem to find the hypotenuse. As we have done this before, if we use the Pythagorean theorem, a squared plus b squared equal to c squared, this side is going to be root 2. The same here. So we see the special right triangle of 45, 45. That means this reference angle is 45. And the same here. So my theta reference is equal to 45 degrees. Now, what is my original angle? The first one is going to be this one. Starts from here and ends at this point. So this will be 0 to 180 minus 45. So theta 1 is 180 minus 45, which is equal to 135 degrees. So that's the first answer. The second one, theta 2, is going to be this angle that starts from here and ends at this point. So to find this one, I'm going to subtract the full circle, which is 360 from 45. So this will be 360 minus 45, which is 335. And that's the answer. So this was our exit ticket, and now it's just sorry, this is wrong. Okay, now it's just the homework. You need to use the link that we're going to provide on Google Classroom to work on your homework. Your homework is going to be another quizzes, so you're going to work on that and turn it in by next Sunday, which is 4/12/2020 at 11:45. Have a good day.